All right. Think we're good. Just checking the levels. Got the mic running. Okay. A little hot there. There we go. Hotter, maybe. Maybe too hot. Just to back it up a little bit. Okay. Hi. Welcome. It's 2026. What a weird start to the year so far, if you've been following world news. But this little corner of the internet, we don't have to worry about all that. We're just doing some programming. Recreationally, for fun, for learning. I'm Agent Ultra. It's nice to see you. Thanks for joining me tonight. On the stream, I do basically mostly functional programming. And we do that in the Haskell programming language, for the most part. Maybe one day we'll branch out, but that's what we're doing. And we got a little project on the go right now. I'm building a mud server. What's a mud server? Glad you asked. A mud server is a multi-user dungeon server. It's a precursor to the modern massively multiplayer online game. They were built way back in the day. They were usually text-based. And that's what we're doing. So kind of real time. It's real time, so you send commands in and you get updates back. And you play with multiple people at the same time. So there used to be online games even before that, but they were turn-based, and you generally only had one person online at a time. Those are called door games in the BBS era. But yeah, mud. We're trying to do a mud server in Haskell. Mainly just for my curiosity. I wanted to mess around with embedding different language runtimes in a Haskell program in order to script add scripting support to Haskell applications, and also to mess around with Haskell's STM libraries and concurrency support. So we get to mix all of those things together and see what we can come up with and build stuff. So we left this off before the holidays. I just took a few weeks away, and I haven't really done a whole lot of programming in that time. I'm not super sure where I left this off, but let's look at the log. I think we were updating the simulation because I wanted to get close to being able to just be able to connect to a character in the server and have the simulation start sending me feedback so that I can like see what I'm looking at in the room and stuff like that. So that looks like a little bug fix commit. It's a little test. We're testing the Lua runtime again. I'm trying to get the Lua code to work. Oh, right, because we were trying to push a Haskell function onto the Lua side of things. That's right. Yes. Yeah, add Lua parser, yeah. Code. And this one, echo function. Yeah, that's the pre-C function right there. So we write functions with the special type here that lets us push these Haskell functions onto the Lua stack for Lua code to be able to call and execute. And I was just trying to get that to work, I think. I don't think we got it to work exactly. We can't look some bug fixing here with the loop. So let's get the server running. I'll run Bakamud. Right, and we had like a code path for our Bakamud code, like our Lua code. Well, we wanted to use the echo function that we push onto the stack from here in the main. I think we just got this print hello from Lua. That should work. The other thing I think I got to start fixing up on this too is how I'm handling spawning the thread, or how this code is handling spawning threads. So as I've noticed a few times when working on this, it is if a thread is encountering an exception or runtime exception of some kind and like terminates, it's not notifying the main thread. Okay, so we got the hello from Lua there. So this main script is getting called, and we're getting a segfault. Address already in use. Oh no. Not possible. How's that? Nope, too many. What port do I run this on? I think 3000. Okay. Weird. Maybe it's just a weird. Oh, resource pity. Okay. Oh, there it is. Oh, I got Tiger Beetle running on that. Okay. No problem. Okay. Segfault still, but that's gone. Yeah, I was doing some work on the old Tiger Beetle library, getting that updated. That should be up soon. Probably this week. I'll cut a new version, and now it'll run on the latest Tiger Beetle client and version, and up to GHC 9.10.1, I believe. Okay, so why are we getting a segfault here? Probably from the Lua code, if anything. Does this binary have debug symbols by default? I want to find the binary so I can actually run it in GDB. Well, how do I get that? List bin. That's the command. Bakamud. That's the one. Let's see if it has debug symbols in it. That's in the foreign code, of course. C string. Okay, it's a kind of a mangled name generated by FFI, but C string is a good hint. So it's probably something in the mud code running stuff. Let's see, server. Possibly from here. Actually, we're not calling this code. So I'm gonna find all the instances we use with C-string len. Just 2 simulation. It could be there. So let's just pop a little trace in here. And see if we can pop one here. Oh, okay, it's not that part. This one. It can't be. We don't even call this anywhere. Maybe I'm wrong, though. Yeah, no. Okay. Didn't think so. I see only 2 places. Could it be in the Lua library, perhaps, and not us? Get rid of all this. Everything's running, sort of, hopefully. This fine here. We allocate a new C string line here and here. Load main module. Load main. Okay. Let's print out that mud main. That's right. So get the code pointer, the code lang. Just I wasn't having this problem before. New C3 lang. I think will, because the mud main module is just a Haskell string. New C string len. Does it introduce a null terminator for us and make it a proper C string? Okay, yeah, it does marshal a Haskell string into a null terminated C string properly. Okay, it has to be explicitly freed. We're not doing here. Can add that though. Free comes from data to foreign. No, not that free exactly. Foreign marshal alloc. One L. Oh, okay. Call Lua resolve bind to free the code pointer. Okay. Let's clean this up a bit. This isn't making it work. I'm gonna remove that. And debug. Nothing here, okay. That's a nice little command. Okay. Alright, so where else could that be coming from? Wonder. Ball. debug symbols. It's a GHC options thing, right? Enable debug info. Yeah, hopefully that'll get us a better backtrace. We can kind of see where it's coming from. Backtrace. Oh, still nothing. Okay. Not super helpful then. Peak C string info. Peak C string. Okay, that's a thing. I don't think we call that in our code anywhere. Oh, we do. Okay. Only an echo, though. Is echo being called anywhere? We push it. Let's try not pushing the function. Maybe it's doing some kind of evaluation or like code gen or something. Okay. That is the problem. Okay. Oh, almost sneezed there. Sorry. Whew. Okay. So that's the issue then. This function has a peak C string call in there that's causing a segfault. Why would it be calling a seg? Why would this be causing a segfault? What does P6 C string do? So we're trying to marshal a null terminated C string into a Haskell string. So if S doesn't exist when we go to get it, maybe off the to-Lewis string function here, it's like a null. That could be it, maybe. It's not a Haskell string yet. It'll be a pointer, right? It'll be a C string. Yeah, which is a pointer to C car. Which means if we print it out, the pointer has a show instance, but it'll just be a pointer address. If it's most operating systems, like the null pointer will be like 0 in the virtual table. Probably on the system too, so that might be helpful to know. We show S. Yeah, Okay, so it's getting like a null string back probably. And the bottom one of the state. I mean, we're just trying to push the function onto the stack. Use from Lua for here. We just use it here. Get rid of this. We just have hello from Haskell. That's it. Okay, no more segfault anymore. So now I'm kind of confused, Lua library. Like, what the heck is going on when we push a function on the stack there? Let's set some globals in those tables. We're doing hslua push hs function. Push is a Haskell operation as a Lua function. The Haskell operation is expected to follow the custom error protocol. C function. So n Lua to integer L prime from the nth bottom off null pointer. Lua push integer L prime, the sum of 1 to n. Return num results 1. So 2 integer x. Converts the Lua value at the given acceptable index to this signed integral type integer. The Lua value must be an integer number or string convertible to an integer. Otherwise it returns 0. If the number is not an integer, it is truncated in some non-specified way. If isNum is not null, its referent is assigned a Boolean value that indicates whether the operation succeeded. Okay, so this is a way to get a Lua number off of the Lua stack into Haskell as an integer. Right. This code here is using 2L string, which is right here. Converts the Lua value at the given index to a C string. Len is not null. It sets the referent with the string length. The Lua value must be a string or a number, otherwise the function returns null. the value is a number, then Lua 2L string also changes the actual value in the stack to a string. This change confuses Lua next when Lua 2L string is applied to keys during a table traversal. Okay, we're not doing any of that. So it returns a pointer to a string inside the Lua state. This string always has a 0 after its last character as in C, but cannot contain other zeros in its body. Because Lua has garbage collection, there's no guarantee that the pointer returned by Lua 2L string will be valid after the corresponding Lua value is removed from the stack. Okay, so we're getting a null value, a null pointer back. Could it be that it's immediately getting... I still don't know why it's actually evaluating the function to begin with. We're not calling it or anything. We're just pushing it onto the stack. And we get this segfault. We're getting the segfault on when we try to peek it. Which we should have a lock on it, on the interpreter at this point. Right. Okay, well, we read in this transaction the Lua state here on line 25, and then we do a separate IO action here to push this HS Lua function echo onto the state. Man, that's interesting. Okay, so if I push that on there and we call what we have right now by, say, adding that. Go. Let's recompile. I'll go into our Lua code. Maybe message. Oh, I gotta prefix it, sorry. Lua. Okay, then we got echo from Haskell. So that works fine. We've pushed a Haskell function onto the Lua stack. We've created the global, and in our Lua script, we've called it. It's ignoring the argument because our implementation just does this string here. Hard-coded. Okay. For some reason, this getting the string argument, maybe I'm not getting the argument out properly here. Maybe that's not how I'm supposed to take thing, or I'm not maybe I'm not properly getting the string, because it said it only get a pointer to it off the stack. So maybe when I'm when this code is dereferencing the string, I don't know, like, again, the thing that's confusing me is like why this is causing a exception when it's like a segfault, an exception when it's not even being evaluated. But nevertheless, the S here would be a pointer to some value in the Lua interpreter that has a string, I guess. So how do I get a Lua string from that? Maybe the Lua documentation knows. In general, okay. So several functions in the API return pointers to Lua strings in the stack. Okay, in general, Lua's garbage collection can free or move internal memory and then invalidate pointers to internal strings. To allow a safe use of these pointers, the API guarantees that any pointer to a string in a stack index is valid while the string value at that index is not removed from the stack. It can be moved to another index, though. When the index is a pseudo-index, referring to an up value, the pointer is valid in the corresponding action. Some functions in the debug interface also return pointers to strings, namely get local, get up value, set local, Lua, set up value. Okay, for these functions, it's guaranteed to be valid while the caller function is active and the given closure is in the stack. Except for these guarantees, the garbage collector is free to invalidate any pointer to internal strings. Let's push all string. Pushes a string pointed to by S with size len onto the stack. We want to pop off the stack. We're going to get the string out. Not quite. It's weird that, so it does that. How do I get to the C string then? Okay, so to call a function, first the function to be called is pushed onto the stack. Then the arguments to the function are pushed in direct order. And finally, you call a Lua pcall. Nargs is the number of arguments that you pushed onto the stack. All arguments in the function value are popped from the stack when the function is called. I mean, I guess that means it like has been executed, jumped and returned. Function results are pushed onto the stack when the function returns. The number of results is adjusted to end results unless end results is Lua multi-ret. Okay. So can I just Lua pop 1? No, that just destroys the element off the stack. No, 2L string is supposed to do that, right? Well, maybe my stack index is wrong. It's nth bottom. Maybe a stack index is wrong. That's why we're getting a null instead. So maybe we want nth top 1. Let's try that. Okay, it's nth top. That's what it was. All right, it works. There we go. We got the echo function from Haskell passing into the Lua stack and then calling our Haskell function from Lua. Chat, this is great. We should be able to add some stuff to this now that we can. We should be able to edit this, reload it, and see it reload the server, and maybe in a development mode or something like that. And then we will get true power. Awesome. Okie doke. Cool. All right, so arguments to functions, top of the stack. All right, let's just make sure this is ready to commit. We're gonna get rid of that hunk. That's good though. Perfect. Great, commit. Bakamud, server, mud code. Fix echo function. Arguments go on top. It's not good Lua. Great. Okay, so that works. That's awesome. What to work on next? All right, I want to work on the output system for the simulation so that we can get the output of commands so that the simulation can send us updates when they happen to the client that's connected to the server, i.e. my client. Once I'm connected. So, the design of that, I was thinking the way that this might work is that the simulation would output to maybe like a ring buffer events that have happened. I'm not sure if this is going to be... it seems pretty reasonable. I don't know. Let me know what you think, chat, as well. Because here's the thing. We have the client connected to the server. Right. Server process is over here. And when it's connected, we have a connection that represents that client. Right, we have that in a map of connection ID, CID, to connection. The simulation sits in another thread over here, right, doing stuff with rooms and avatars and mobs and stuff like that. And some of those things that happen in the course of the simulation running, each tick, right, it's going to need to tell the connected client, like, what's changed. Like, maybe a mob has moved into the room that the current user's avatar happens to be sitting in. Right? So I want the simulation to be able to output these events somewhere. The things that have changed, right? An avatar entered a room, a mob entered a room, an avatar left a room, a mob left a room, that kind of stuff. An avatar, a client connected to an avatar, or whatever the event would be called. Right? And so the simulation kind of updates, calls all the users' code, all the systems, updates all the systems in our entity component system inside the tick, right? Does all those updates, and then collects those updates, the things that have changed, into some kind of, I'm thinking maybe like a circular buffer. That will serve as the output. Right? That's my wonderful circular buffer diagram icon. This should be like an arrow. Anyways, it outputs all of those updates, the things that have changed, to a circular buffer for some process to consume, or processes potentially to consume. It'd be like a one-to-many. It could be like a one-to-many sort of situation here. So that a thread that's interested, for example, in updates for this particular client could be spun up and feed those updates to the client connection. Right? And so it's just reading off, and just looks at the event and says, is there the avatar ID that I'm interested in on this event? Or does this event even have an avatar ID? If it does, is it the avatar event that's associated with my connection? If it is, great. I will take the output of this and put it on the output queue for this connection. And that will send it over to the client. All right, there might be other systems or like threads connected to this output as well that might like log all the things that have happened for like debugging purposes or something. And what have you. Right. You might also want the simulation to be able to react to... well, we do want the simulation to be able to react to things. We want to be able to... but I think that'll be fine with ECS. Yeah, this would be enough. We don't need anything that listens to this output buffer to like input things back into the simulation. Right, because there'll be the main script which will control global things. There will be the ECS scripts that will control all the updates for all the entities as they interact with each other, and all the interactions. And there will be a bunch of scripts for handling the input commands, which will be a source of events for the simulation as well. Or a source of inputs for the simulation, yeah. That seems pretty reasonable, I think. Is there anything wrong with having multiple consumers off of our output there? Or should it be one consumer dispatching to many places? I kind of want to, I think maybe we can do multiple consumers. They're just reading, they're not modifying the circular buffer. Only the sim owns it for writing. So it should be safe to be able to do peaks off of this structure. Or full-on drains. Like reads. Right? I think that should be fine. Let's see. Haskell circular buffer. Or ring buffer. Okay, this library is a thread-safe implementation of a mutable ring buffer built upon a vector. Okay, do we have an STM-ified ring buffer? We could also just do an STM queue if we needed to. It doesn't have to be a ring buffer. Yeah, a ring buffer would just basically like overwrite older entries, right? So you keep a bound on it. Right, and so since we're just interested in observing these things happen, not necessarily having like guarantee delivery of them or anything like that, I was thinking a ring buffer might be the way to go. No immediate results in the ghouls, which I'm not super keen on. Yeah, you've got queues, channels, semaphore locks, and vars. Could use another T-chan maybe if we needed to. Channel. Could be one way to do it. The only thing with channels is that they buffer up messages until they get read. Unbounded. So that could introduce some failure modes. STM collections, or was it collections or containers? Just maps, multi-maps, by map sets. STM. Well, no STM circular queue or ring buffer for us. This library purports to be thread safe. It could be safe. I can't guarantee that, but STM would make me feel better. Because that's what we're using. Mixing this in might be a little bit tricky. Let's take a look at a little bit of the code here. Okay, it keeps calling the ring state and the actual vector using a prim state IO token, I guess. With ring. Alright, so use an mvar to read the ring state. Run the state computation in a reader. S prime, the next state. Puts it back into our mvar. Return the result. So it's sort of, I mean, the mvar is kind of gating us there. So like, maybe we could use this. It just means I have to mix IO here, which is not desirable. We can't run IO actions inside a STM transaction. Would there be any reason to worry about that, actually, is the other question that we should ask ourselves. If we look at the server state, so this part of the system is going to be, some thread going to be reading off of this ring buffer. If it's reading off in IO, and it has to interact with our connections map, and that's held in a map and a tvar, which it's probably, we have to be super careful with using tvar maps here concurrently. Yeah, because updating, we can't update the map concurrently. There's a good blog post about that that explains why from Matt Parsons, and it's also explained a little bit in this book here, Parallel and Concurrent Programming in Haskell. But concurrent access to keys is the thing. All right, so we'd have to lock that to make sure that we aren't doing any concurrent updates to the map itself, i.e. updating the outputs. So in this IO ring buffer world, we could do that. We can access this T-bar, access map. We'd have to like be careful with that block there, but it does mean that we can only send an update to one connection at a time. All right, we'd be locking ourselves there, blocking ourselves there. So I'm thinking maybe we should try the channel, or I don't want to say a bounded queue, but maybe a bounded queue. Or I convert and I write an STM, or I write an STM circular buffer, a compatible one. We change this to an STM-ified map from the STM containers package, and then we can update connections and concurrently, multiple connections at once. There could be multiple threads reading off of that channel, updating multiple connections with their output at the same time. And then in that scenario, the only lock would be on the key, the individual key. So which is fine because we're going to be doing processing those outputs in serial anyway. So, yeah. But if we wanted to update 60 connections with 60 different outputs at the same time, that would be fine. Okay. Yeah, let's try the channel route and see how we do. Where should we put this? Simulation. Okay, simulation. Right now, the simulation is just a function in Bakamud server. Right. But it's going to have more than that eventually. It's going to have its own data for the map, the rooms, which we've been working on, and it's also going to need various other things. It's going to run in a Bakamud server thread. I wonder if there's a way we could bundle it up. And do a type here, what the data we need for the simulation. Like the output queue, output channel. Outchan, maybe I'll call it. Outchan. Pikachu, Pikachu, Outchu. I don't know. Wait a second. Let me look at that again here. That ring buffer. Is it based on STM? Am I just missing it? Test suite, sorry, library. Primitive exceptions MTL vector based. Yeah, no, it is just core control.concurrent, so not STM. Okay. So our teachan type is going to be a teachan of some A. What's the A going to be? That's going to be simulation events. Teachan of sim events. What's a sim event? Let's say client connected. You give and show. You can make this a state. And yeah. We got a builder going. GHC ID. Where do we put client ID? What was it? Network connection? Yeah. Connection ID. It's network connection. Like that. Yeah, we can't have a show instance on there because of the teachan. Oh, it's redundant. Oh, because it's already re-exported from STM. Okay. My bad. Oh, good morning. Yeah, we'll fix that in a separate commit. Presumably that's fine. Or I will stash this for now. Fix that. Oh, thanks for the follow. Tiz2-1. You made a great decision. Welcome to the stream. Do you do any Haskell programming, or are you just curious? Well, let me know in the chat that you're not just a bot or something. You know? Say hi. Just curious. Cool. Well, it's nice for you to pop in, and hopefully I'm satisfying your curiosity. If you have any questions, I'm totally open to answering them, no matter the question. Diversions and distractions and such are fine. Oh, cool. You want to start learning Haskell? Or just functional programming in general? Yeah. wants us to use HSLua, set global, which is a different function with a different type. State C string and C size with pointer to status code. Okay. Do I still think it's worth learning? I think, do you mean AI progress? I'm not sure what IA progress is. But if it's AI progress, I think it's absolutely worth learning. But you're gonna need some motivation because Haskell's, depending on what your, I don't know what your experience is and such with programming in general, but myself, for example, I started learning Haskell about 5 or 6, well, I guess it's 2026 now, so like 6 or 7 years ago. Probably around 2018, late 2018, somewhere around there. And I'd been a programmer for like 20 years at that point, something like that. And so I had a lot of experience in like C-like languages, like C, Python. I've been doing JavaScript, for example. And I found it particularly difficult when starting Haskell for a while. But I had a personal motivation to get through the difficulty, because I'd actually tried learning Haskell like a bunch of years before that, around 2008, and completely bounced off it. And I think I bounced off it the first time because I had like no reason to go far with it. So when it got hard, it was easy to find other things to do, and then it just kind of fell by the wayside. And I would warn that just learning Haskell will make you a better programmer. Potentially true, but it's not going to motivate you enough to keep going, if you know what I mean. Right? Because for myself, at least, when it came to, like, when I first started learning, I was like, okay, I know how to do basic hello world web application. I'll look at a tutorial and get something going. So I looked up a tutorial like Spock or something, some web framework for Haskell. Followed the hello world and got it going. It was right. Cool. And I was like, okay, well, the next step, what do I want to do? I want to modify this now using what I know to add logging, say. And I'd taken some Haskell tutorials at that point. Like, I'd figured some things out. But for the life of me, I couldn't get logging to work because I needed to learn something called monad transformers. And I had no idea what the heck a monad transformer was. So I tried looking it up, and the documentation on it's just, it blew my mind, let's say, and made me very frustrated. Very new to this, and heard companies don't need so many developers anymore, and it's hard to find a job as a junior. Oh, yeah. I feel you. I'm on the job hunt right now, and it's brutal. I have a lot more experience, and it's still brutal. Being a junior is probably terrible right now, for sure. Will learning Haskell get you a job? No, I don't think so. I don't think it will. There are very few Haskell companies. Some of them are pretty good, but there's very, very few of them. And so you could apply to all of them in a week. Less than a week. Like, there's just a handful, really. They don't... Only one of them hires regularly. So your mileage may vary there. I would say, like, a good motivation would be like, okay, well, there's a particular project you want to build that you think would benefit from Haskell. Like, something that's interesting to you to build. So like a game or, you know, a little application for yourself that you need to, like, manage, I don't know, your hobby or something, right? Just satisfy your or maybe something just satisfy your curiosity. Recreational programming is also fun. So like just doing coding exercises in Haskell. But precisely just to learn functional programming, because like you just want to know like what a monad is, how do they work, that kind of stuff. Yeah, it's not a very popular programming language for working in. It's a very cool language though, or working in though, if that makes any sense. And you know, some friends of mine say like, you know, a hiring manager who's technical is going to look at a resume and see Haskell and go, this person went through the pain and the struggle to learn Haskell. It's not actually that painful. It's actually really fun, but they went out of their way to learn this language that isn't super popular, that it has like a reputation for being quite challenging, and made something with it. And so that might make you stand out a little bit. And in this day and age, I find a lot of hiring managers aren't super technical. And so they're just keyword matching. And they don't see Go. They see Haskell, but if they don't see Go and they're looking for Go, they're not going to go, oh, a Haskell programmer could learn Go pretty quickly because they learned Haskell. Okay. So that might be different if the place you're applying to is like you're sending somebody a resume on a first name basis who you know is a technical person who would look at that and go, oh, okay, they learned Haskell. They made a couple of projects in it. We do Go here, but they could learn it pretty quickly. Right. I don't think Haskell's a very good signal is what I'm saying for programming competence these days. Yeah. Just learn it so you can have the galaxy brain, right? You'll be like, oh, I know Haskell. And people go, ooh, or they go, which is the reactions I get. I speak at a local programmer meetup every now and again, and everybody knows I do these programming streams and in Haskell, and they know I do Haskell programming. I've done it for a living for a few years, so everyone's always pulls my leg about Haskell stuff. But I don't often talk about it actually at that meetup. Okay, so HS Lewis set global has a different type here. C string, C size. So I got to change this line here on 28 a little bit. To a C string len. I'll give it an anonymous function that gives us the L and the L len. And that way, I have that. State C string L. C size is the L len next. And pointer status code. It's going to be in the null pointer. I don't think I'm going to check that in this particular case. And then I need to put a little $sign here. Null pointer isn't. Oh, I need the state as well. Oh, okay, I'm overshadowing the name. Oops. Fun name. Function name length. Okay, then we just need null pointer. Which I think just comes from foreign.pointer. Architect Ent, what's going on? Yeah, Lua integration through Haskell. Yeah, it's nuts. I got it working so that both ways now. So you can using this library. I didn't write the library. I'm just using it. But somebody wrote a Lua interpreter wrapper in Haskell. So I got it passing a Haskell function to the Lua interpreter, which the Lua code can then call. So they can execute the Haskell functions we give them, and I can call Lua functions from the Haskell side as well. So yeah, the spec for the idea for this project is a multi-user game, right? It's a text-based multi-user game called a MUD, multi-user dungeon. And I'm writing the engine part in Haskell. And so the game design, the game development part, there's going to be like a user of this who's a game developer who's going to be writing their code in Lua. And so I'm going to provide them hopefully with a decent enough API to get things done and build things with. And then we use Haskell underneath for like high performance networking and like concurrency and stuff. And all those bits. So you can just focus on the game code. Not worry about it. That's the plan anyway. I don't know if it's actually going to work out, but we'll see. Okay. So then function name length, C size, actually int. We want the parentheses off. Oh, because, yes, this is a nuisance. With C-string len, gives you a tuple here of argument, or gives you, yeah, a tuple of arguments here. The string, the C string, and the size of the C string. But instead of giving you it in a C size, which is a size of, on the C side of things, it gives you as an int. And then you have to convert it yourself, which is so, it happens a bunch of times in this code already, and it super annoys me. Gosh, I wish that was fixed. C size, I think, no. And then I have to do from integral. Good gosh, that is a go. But it works, it compiles at least. Okay, it gets rid of the warning. Right, so I'm just running the server here now, and this is called from the Lua script, main.lua, which is like the kind of going to be like your main entry points, because it's going to run like global stuff. And yeah, prints out our little string. This is just plain old Lua code. Pretty neat. And that echo function is Haskell function. Defined here. Pretty cool. You do similar things in C++ or whatever if you're using embedding Lua, right? You can do it in Haskell as well. Turns out Haskell's FFI is pretty nice, I gotta say. As far as FFIs go. It's not quite as smooth as like something like Zig or Odin, where they can do, and they do, at least on the Zig side things, well, they don't have to marshal as much. In Zig, you still have to do some marshaling, but you can basically call C code without having to make any other definitions. And it actually uses similar tricks that Haskell uses. Whereas Haskell can do that. You can just import a C header file and start calling code from it. There's just, when you start having more complicated structures like structs, you're going to need to write some Haskell code for it. And so there's programs that will do the generators and the bindings to do all the marshalling for you. I do a lot of that in a library I worked on this stream for the Tiger Beetle database. There's now an open source community client database library in Haskell for Tiger Beetle, which we wrote here. Anyways, so yeah, I'm going to commit that. That's just a tiny little thing I wanted to fix up. Modify Bakamud simulation. Fix warning. Fix deprecation warning. Okay, cool. Now let's get back to, got a little bit of time left. I don't know if we're going to have a ton of time to do this, but where we were with the simulation and getting that set up. Okay, the out channel. So we're using the STM library, the software transactional memory library here in Haskell to handle a lot of the quirks you have to deal with when you're dealing with multi-threaded or like concurrent applications that share memory, right? You got to make sure that things get locked and updated atomically in a lot of cases. Sometimes you don't need locks and you can do lock-free things, but we're using STM so that it can kind of do a lot of these transactions for us appropriately. We don't have to do manual mutexes and things like that. So the idea for the simulation, right? So the server like runs, and in it, it has a sim that's going to run on a tick, right? We have all the tick code down here. It's kind of messy, but like a frame, think of it like a frame rate. It's going to run maybe once a second or 60 times a second or whatever the tick rate's going to be. And what we want to be able to do now, what I'm working on, is collecting all of the updates that happen in a tick and sending those out to the connected clients. All right, so I'm trying to figure out the architecture for that. So we can do it so that we can have multiple threads reading off of this output channel, and each of those threads could be updating one of the connected clients that are connected to the server. Right? So the first part of this is a T-chan, a channel, like basically a broadcast channel. And the other part of it that I think I'm going to need to change is the map that we use for the connected clients, connections, basically. And, yeah. The only thing is, with the channel, is I don't want to... Read is probably going to remove an element from the channel. Architect end. Intriguing seeing something very typical being done on a very uncommon programming language, let alone one here that's an uncanny mix of other languages. Yes. I know. It is a little weird. I'm figuring out how to do it in Haskell too. Like, I don't think I've like worked with mud code in a very long time, but it was C back in the day, which is very different than this compared to this. It's kind of cool. It's kind of cool. But anyways, I just want to make sure we have an operation that doesn't remove elements, because my idea for the architecture is that multiple threads are going to be reading off this one channel. Oh, there it is. Yeah, get the next value from the T-channel without removing it. Retrying if it's empty. Okay. So we'll have to have a consumer to consume these eventually so that the channel doesn't just fill up indefinitely. But if we have multiple readers from it that are trying to update all the, like maybe one thread per connection, right? We don't want that like popping off an event and going, yeah, this isn't for me, and then nobody else gets to see it, right? Which is why I kind of want to maybe think about doing a circular buffer, like an STM circular buffer, which you weren't watching earlier. I was humming and hawing about having to write ourselves because there doesn't seem to be one. Because an STM, a circular buffer would be different than a channel, right? The structure is basically, you can think of it like an array where we just overwrite old elements, right? And so everybody sees the same thing. Or anybody who's listening can see everything, and it doesn't remove elements. They don't remove elements, it just overwrites old ones. And so the idea with the connection thread, just kind of watching the stream of events or events that interest it, you know, that it wants to know about. And it goes, aha, there's one for me. Put it on the output queue for the connection. Right, but I'm trying to do it with channels here to see if we can do it with channels, but yeah, I don't know. But the next part of this we are going to have to do is change. Let's get our kind of builder going, our interactive builder going. The server state here keeps a map of the connections in this like thread variable, tvar, which is like a concurrent, atomically updated variable here. There's a slight problem with using this pattern of tvars over maps when you're updating maps, which we can fix because there's a library that has STMified maps. I think I have the dependency already specified that we can link to it. STM, oh, we don't? Okay, so we can add it. This is probably going to break a bunch of stuff, so I don't know that I'm going to have a ton of time to finish this week. But it's STM containers. What's really cool about these is that they can support concurrent accesses to the map. And so you get a little bit more finer grain when updating the map. So instead of like taking a lockout on the tvar in an STM transaction, then updating the map, right, and then writing the map back to the tvar, and then ending the transaction, right? This can go down to the key. I can lock a particular key. So now we could update several connections at once. If we have a thread per connection to write to its output queue. So let's see this library. I think we probably want to try 1.2.2 first. And STM containers.map is the import. Here. Yeah, I also have a tvar for that, so we're gonna import a qualified. As smap. I'm going to load and compile all of that as we go, and hopefully not give us an error. Although it probably will give us an error because we can do that, but we can get rid of the tvar off of that. The thing I like about programming in Haskell a lot too is like errors are actually awesome. Not in that like sometimes the error messages, all the error messages are great in like the rest sense of things, although the error messages are pretty good. But they are, it's just, I like the interactivity of like messing up some code, completely changing a type of something, and then getting this error and be like, what do I need to fix? And then I just keep fixing the things until the errors go away, and then my code compiles again. And everything is awesome. All right, so here it's saying like, oh, I expected a type, I've got a different type. That's because I just changed a type, obviously, right? So here, right, this has got a tvar of something. That's what the message is saying. I got a tvar, and this like A0 is just like something. I don't know what it is. Right, that's a type, but it's just some type. I don't know what it is. And I expected, though, an smap map. So we got to change that. How do we change that? Well, this is where we get the server state tvar, or sorry, connections server state tvar. Yeah, okay. Yeah. Right. So we need to construct an STM containers.map here. We can call new IO to construct a new map in IO. I think is what we're in right now. Yeah, IO. That's map. Does it take an argument? No. Okay. Server state connection. That was the wrong one. What was the right one? Server state connection, server state tvar. I don't know why it's called that. We can fix that here. Connections map. I just lost the. There it is. Okay. So I go smap, new IO. Right. Okay. Oh, that's not in scope. Yeah, no problem. All right, now it's like, oh, okay. The next error, right? It's in client. I use this somewhere. Where did I use it? I used it in client.hs. Let's go fix that. Read tvar, connections tvar, right? That's not tvar anymore. In fact, we should probably call it something else now, isn't it? The connections. Alright, it's thinking it's a tvar and we're reading a tvar. Not the case anymore. In fact, we use that to get the map out. The read tvar is how you read one of those variables, the value out of that variable. The atomically is the function that runs an STM transaction. So we know we're in a transaction block right now. So this is like basically taking a lock on this tvar at the moment. If something else was, another transaction was looking at this tvar, it would have to wait until we're done with it. And that's all taken care of by the atomically function, the monad STM. But anyways, I'm glossing over a lot of things, but if that makes sense, great. If it doesn't, you can learn. There's a great book here. It's called Parallel and Concurrent Programming in Haskell. It explains a lot of this stuff. Written by the person and the engineer and developer who basically built all of these libraries. Or at least did a lot of the work on them. Okay, so we don't need to read the tvar to get the map anymore. We can use smap to update it. So we can just get the connections map. I think I renamed it too. No. Server state connections still. Okay, so we ask for that from the state. And how do we update things? Look up, insert, delete, reset, unfold, list T non-atomic. Okay, so we want to focus on the value by the key, and we can look up a value and delete it at the same time, or update it and return the new value. Cool. So what we're doing here is inserting. So we could just do a straight ins. We're doing a lookup first. And then we're writing a message to that connection's output. So we're just reading it, basically. So we just need the lookup. Yeah, it's smap. Okay. replace this with smap.lookup. We don't get maybe there. You get a key in the map, and I get an STM. Oh, an STM of maybe value. Okay, so that should still be that. Connections map. Yeah. Okay, so we can't pattern match directly on the lookup here. This is not returning a maybe, it's returning an STM that contains a maybe. So we have to bind that value inside our STM block here, and then pattern match on it. So I'll call it maybe connection. Well, I just got to pop that up, this expression up here, replace it with maybe connection. Put that here. So this is the reverse arrow here, like the bind, instead of a do block. It only exists there. That should work. Okay. And now this type error is saying I can't figure out hashable connection ID. Right? That's a type. It's called a type class constraint, and that's coming from this here. All right. So everything before this fat arrow is like a constraint on key. Key is a polymorphic type variable, right? A polymorphic type variable means it could be any kind of type in the set of possible types. So we have to constrain that in order to be able to use it, do anything with it. Because if it's any type, then there's what operation? It could be any operation, right? So you have to put a constraint on it. So it says it wants the constraint to be hashable. Right, now we don't have an instance of hashable on connection ID. So we could go and add that connection here. All right, hashable is all hyperlinks. We can just go look that up. Comes from the data hashable package, which I think is its own library. So we're gonna have to put this as a dependency, which is probably already a dependency of STM containers, so it's not gonna be huge to recompile, but just make it explicit. Hashable. Let's see. 1.5.1.0, let's try it with that. And we'll have to reload GHCID for that. Okay, and then we can import data hashable. And I don't think it's stock deriving. So this is the type class definition. Right, type class hashable polymorphic variable of A. So whatever type we want to make hashable, it just has to have we have to be able to compare it for equality. And if we implement these methods on the type class, then we can call that thing hashable. I'm wondering if these are derivable. We could use generic. I'm not opposed to generics, but you have to be careful with generics on larger code bases. They can slow down your compile times a little bit if you get a little too carried away with them. We can write the instance by hand, which I don't want to do because blah. All right, let's do generic. So GHC implements generics for us. And then we should be able to do instance hashable connection ID. There we go. Voila. Next part. Let's see, we're running a little low on time. See if we can figure out where the next thing is and see if we can do that. 40 in server. this is probably where we add the connection. Oh, we update the authorization state of the connection. Line 40 here. Yeah, our really weak, very basic authorization system at the moment. When we connect to the server, you know, it's open if you're running it on a server. Yeah, I mean, you could jail it, maybe limit it and waitlist your allowed connections if you want, but presumably the idea is you want people to be able to connect to your server over the internet to play your game. So you gotta authenticate before you can start doing stuff, more privileged things on the server other than like read the welcome message, like try to log in or register a new account. Kind of like you would with a web application, right? Which is kind of funny because this stuff came first before web applications. We figured out how to do it. Now we're figuring out how to, I'm gonna have to teach it in reverse from the way that I learned it. Because more people are familiar with web applications than they are with command line text-based servers. Anyhoozle. That's why we do this, right? That's why we do this. All right. Yeah. Okay, so we're gonna do the kind of similar thing. This is more like connections map. We're not gonna modify the T-bar, but we are gonna use that handy dandy STM function. Focus. This is an interesting type here. What is a focus? It's an abstraction over the modification of an element of a data structure. Okay. So I get one of these. This will change to atomically do. And then a map adjust is basically what we're going to be replacing with this focus business. So I'm not sure how to use that exactly. How do I focus on it? What do I do to create a focus? How to create one? Reading functions modifying. Okay. Data map.update. We use adjust. Is there one for adjust? Yes, adjust. Okay. So this will give us a focus. And we give it a function as an argument, an A to A, which is going to be, I'm guessing the A in the focus is the element, the key. No, the element. Yeah, the element. Okay. I need the focus library, I guess, as well. I go 3.2. empty do block, that's fine. And let's just focus. I'm going to import qualified focus. Let's focus. Okay, so then our adjust. Update auth success. Focus. One way to spell it. Focus is then focus.adjust update auth success, and we can make this, and then what do we do with the focus? We pass it into STM containers map. Focus, right? smap.focus. And we give it the map, which is connections map. And we have to import that. STM containers map as smap. 44. Not quite right. We give it the focus and the key we want to focus on the map. Key, the key. Connection ID, right? Yes. Boom, okay. Sweet. We're a little over, but you know, it's the first stream of the year. Happy to go a little longer. See if we can get this next one. Server, network server. It's a little bit of the lower level part of the engine, where we handle like the network connections themselves. Right, so this is updating the map to add a new connection. Let's add the name add connection. So the same as before, we're going to need focus. Yeah, it's not so bad. We got over it. We learned. Import qualified STM containers map as smap. Okay. Then take out all of that. Connections map. Okay, so then our maybe add focus. Focus.alter. Maybe add. And we should be able to smap.focus. Maybe add focus. Key, connection ID, map, connections map. Like that. Then we don't need that import anymore. Or no, this is server client. There we go. Let's see if this still works. So it compiles. Will it run? Will it work? Okay. That's all good. We can actually connect to the server at the moment. We have all the connection handling stuff done. So I'll boot up a little mud client, a multiplexing mud client called Kill the Client. This one's been around forever. Yeah, let's connect to it. We're connected to the host. Typing some stuff. Maybe, oh, it's connected, but we don't have anything else set up. I think we can log in, foo bar, stuff like that, but it's not logging things out at the moment. So we'll get that working back again once we got, now that we got the simulation command loop and stuff going, but that'll have to be for next week. So yeah, let's close. And that's it. That's what you got. That's what we got. So yeah. Bam. Yeah, I ripped out a bunch of stuff that all the handling. I'll just have to put that back in order to test out the Lua code handling stuff. Okay, so let's create a commit for all this. Let's just review our work. Okay, so we updated the Cabal file, added a couple of dependencies for STM containers. Right, connection ID has a hashable incidence now. And we replaced basically the main change is in state, where we added an STM map, an STM containers map for connections. Yeah, this is all in preparation for us to be able to hook up that simulation output channel to the threads that are going to read from that channel and update this client map. And they can do that atomically in these using the same STM transactions. So yeah, let's add all those. I don't think I have any debugging, and then we just updated a bunch of we haven't committed that yet. We're gonna leave that one out of this commit here though, and just put the state stuff in. All right, modify Bakamud server state. Added dependent focus STM container hashable dependencies changed. Server connections map is an STM containers map. Updated all places that modify it. Done. Okay, so if this is your first time tuning in, thanks for watching and hanging out with me. All the code that you've seen tonight for this server is called Bakamud. It's up on GitHub. I'm Agent Ultra, and I'm also Agent Ultra on GitHub as well, where we have Bakamud here. So I'll paste that for y'all. Copy that, paste here, boom. If you want to follow me on the socials, I am on Mastodon. I'm on the types.pl server at Agent Ultra there. You can also go to agentultra.com. That's my website. And I have links to my YouTube channel, where I back up the VODs for this stream, as well as links to my GitHub and various other places and projects and things like that. If you follow me on here, short updates, mostly on programming stuff. If I do post things that aren't like program related, I try to content warn on those or whatever, and like maybe I'll repost things. But if you like what you saw tonight and you want to know about the stream and stuff, what's going on, good place to follow. Also my blog and such as well. What else? Link above my head. Great little community building there. It's a bunch of streamers who are doing things in declarative programming languages like Haskell, but also Erlang and Elixir and various things. They also have streams, and there's a whole community there that you can join. find their schedules, see what you like, browse, and all that sort of stuff. There's also a link to a Discord server where we have a channel for this stream. So if you're watching from YouTube or you think of a question later that you want to ask, feel free to join the community there, join the Discord server and ask away and hang out with us. That's all I got for this week. I usually do these streams at 10 after 8 in the Eastern Standard Time Zone, so if you want to write that down and just join next week, or you can follow me here on Twitch, or like and subscribe on YouTube and get notified when I go online and do these streams. That'd be great, and hopefully you'll see you then. Until then, happy hacking out there. May all your monads be free. May your types always check, and we'll see you.